when the light travels from denser medium to rarer medium, angle of refraction is greater than that of the angle of incidence. So when the light travels from glass to air, as the angle of incidence increases, angle of refraction is also increases. For a particular angle of incidence, the refracted ray does not enter into rarer medium, but it grazes the interface of both media. That means if this is the glass and this is the air, so for a particular angle of incidence, the refracted ray grazes the interface of both media. Here the angle of refraction R is equal to 90 degrees. This angle of incidence for which the angle of refraction is 90 is called as critical angle. So critical angle means it is nothing but the angle of incidence for which the angle of refraction is 90. If R is equal to 90, that means angle of refraction is equal to 90, then angle I is equal to angle C. Here C is the critical angle. According to Snell's law, we know that N1 sin I is equal to N2 sin R. Here if R is equal to 90, I is equal to C. So N1 sin I, that means sin C, is equal to N2 into sin 90. Here N1 by N2 is equal to sin 90 by sin C. Sin 90 equal to 1, hence it is 1 by sin C. N1 by N2 is nothing but N12 is equal to 1 by sin C. That means the relative refractive index of the denser medium is equal to 1 by sin angle of critical angle. So sin angle of C and that means N is equal to 1 by sin C. This is the relation between refractive index of the denser medium and the critical angle. N is equal to 1 by sin C. So when angle I is equal to C, angle R is equal to 90. What happens if angle I is greater than C? That means angle of incidence is greater than critical angle, then light ray does not enter into the rarer medium. Instead of that, it reflects back into the same denser medium. So this phenomena is known as total internal reflection. That means when the light ray travels from denser medium to rarer medium and the angle of incidence is greater than critical angle, then the light reflects back into the same denser medium. The phenomena is known as total internal reflection. So from this we conclude that for total internal reflection there are two conditions. One, light ray must be traveled from denser medium to rarer medium, and the second one, the angle of incidence is greater than that of the critical angle.